Testing 1 2 3. Testing 1 2 3. Hi, Maddie.
Hi.
Hi. Make sure your camera is turned off.
It is.
Okay. Give me 1 second. Can you see my screen?
Yeah.
Okay. Okay. So we're going to go through basically Algebra 1, and I know that this is going to be a review for you, but I just want to make sure that we have a strong foundation for um, what you're going to be doing going forward. So if you're curious about what we're going to be, the things that we're going to learn, it's going to be right here under Algebra 2. Go to Curriculum. Today we're going over variables and algebraic expressions and then introduction to equations. But these are the other subjects that we're going to go over. Okay, so let's go ahead and start. All right, it's the very first lesson, variables and algebraic expressions. Okay, a variable is basically any letter symbol like A, B, C, X, Y, Z, and it's used to represent unknown quantities. So given an equation like x plus 3v plus z squared, the variables in this case would be x, v, and z. Okay? So these are the unknown variables. And again, it's used to represent unknown quantities. And what variables do is it basically allows us to model what happens in the real world. So here's an example of Bill's bike rental shop. And it's a place that you go to where and pay money to rent a bike, and you can see that it has the hours and the prices listed. So you have 1 hour, 2 hours, 3 hours. So for 1 hour, it's 550 times one. For 2 hours, it's 550 times two. 3 hours, 550 times three equals 1650. And if we were to write an equation for this scenario, it would look something like this. So we have 550 times H, where H stands for hours. And that's going to equal total price of the rental for that hour. Okay, so
Okay.
yeah, so 550 is the price, and then we have H for hour, and you can plug in whatever many hours is allowed for H. So if you ride a bike, if you rent a bike for 5 hours, you would plug in five. If you rent a bike for 3 hours, you would plug in three. And it will always give you the correct price for that bike rental. And what we're doing here, when we plug in a value into a variable, what we're doing is called substitution. It's the process of replacing a variable with some value. Okay, anytime you plug in some value into a variable in an equation or an expression, it's called substitution. Okay, so let's try an example. It says evaluate the following expression for x equals squared. Anytime you see the word evaluate, It means plug in.
Okay.
Okay. So try that and let me know when you're done.
21.
Yeah. So 3 times 6 plus 3. It's going to give you, okay, 3 times 6 is 18. Plus 3, 21. Yep. How about this one? It says evaluate the following expression for x equals 3 and y equals 2. And something you need to be aware of, we haven't gone through this yet, but I'm pretty sure you've gone over it before. Uh, this is PEMDAS, and what they're referring to is the order of operations. So P stands for parentheses, exponents, and given given a set of operations involving multiplication and division, you're going left to right. Okay, left to right, and then given addition and subtraction, you're going again left to right. Some I know some people tell you that it doesn't matter what the order is between multiplication and division, but you want to stay consistent, and you will never go wrong if you go from left to right. Okay, given multiplication and division, and then given addition and subtraction, again, you want to go left to right. Okay.
Okay. My answer is 1.
Okay. Let me. So 15 minus 21. So I got -6. Okay.
Wait, it's supposed to be 7 times 2 because it's a y.
Oh, you're correct. Sorry. So 15 minus 14. You're right. It's 1. Okay. Let's try another one. Again, it says evaluate the following expression for x equals -2. And let me know when you're done.
$33.
All right, let's see. So 10 times -2 squared plus 3 times -2 minus 1. So -2 squared is 4. 10 times 4 is 40. 3 times -2 is -6. And then we have a -1. -6 and -1 is -7. So we have 40 minus 7, which is 33. Okay. All right. Let's continue. So here are some of the terms that you need to be aware of for algebra, and you'll continually run into them over and over. The first word is term, and it's basically a single number or a variable, a number times a variable, or a number times more than one variable. So 3x, 3xy, 16xyz, negative 5y, negative 5a squared, b squared, c squared, etc. Okay, so these are terms. It's a combination of an integer that's a coefficient and then variable or variables. So given this expression, what are the terms? Is this a term?
Yeah.
Yeah. Is that a term?
Yeah.
Is this a term?
Yes.
Yeah. And is this a term?
Yeah.
Yeah, they're all terms. A coefficient is the number in front of a variable or variables in a term. So coefficient in this example is 3. In this example, it's 16. This is negative 5. Okay, those are called coefficients. A constant is just a number by itself. So 7 is just by itself, so that's a constant. In this expression, 7 is the constant again. And then in this expression, the 1 is the constant. And finally, algebraic expressions. Algebraic expressions is one or more terms separated by plus or minus signs. So, okay, it's one or more terms separated by plus minus signs. So, is this an algebraic expression?
Yeah.
Yeah, it's two constants. It's it doesn't look like an algebraic expression, but it is, okay? Because there are two constants and there's a minus sign in between. What about this one? Is this an algebraic expression?
Yeah.
Yeah. Anything with variables and coefficients and they're being added, subtracted, etc., is an algebraic expression. Okay, in other instances, you're going to be asked to simplify algebraic expressions. So in this one, you could use what's called a distributive property, which is where you multiply what's in front of a parentheses expression by the whatever is in front of it. So we would end up with 9x plus 27.
Okay.
Yeah. All right, like terms. This is very important for algebra, and it's where you have terms with the same variables and where the same variables have the same exponents. Okay? So they have to have they have to meet both conditions. They have to have same variables, and then they have to have same those variables have to have the same exponents. So example 1, are these like terms 5x and 3y?
No.
Yeah, they're not like terms. Here we have an x and here we have a y. So no is the answer. What about this one? 3x squared and 6x squared.
Yeah.
Yeah, x squared, x squared. So these are like terms. What about this one? 15x squared times y squared times z and 2x squared z times y squared.
No.
Yeah, no, not like terms. Because even though they all have x, y, z, the exponents are different. Combining like terms. So this, again, very useful for algebra 1 and 2, combining like terms. It's when you add or subtract like terms, okay?
Yeah.
So we're given this example, 5x plus 5x. Well, when we combine them, we're going to get 10x. Okay. This is not 10x squared. We're not multiplying, we're adding or subtracting. And in that case, the variable part will stay the same. Okay, so if this was something like 5x squared plus 5x squared, we would combine them to get 10x squared. Okay, the variable parts stay the same. You're just adding the coefficients. What about this one? Can you combine like terms here? We have 5x plus 5x.
No.
No, because they're not like terms, so we can't add them. This is the best we can do. All right, let's try this example. Go ahead and combine the like terms in this example and let me know when you're done.
I'm done.
Okay, so the like terms here are 6x, 5x, and then 5y, y, and then these are your constants. So let's combine them. We have negative 5x and positive 6x. That's going to give us x, okay? And as soon as you combine like terms, you want to cross them out so it's easier to track what's happening. And then positive 5y and negative 5y, sorry, positive 5y minus y is going to be positive 4y. And then the constants will sum to negative 2, negative 7, negative 1. That's going to be negative 8. Okay, so we have x plus 4y minus 8. Is this what you got?
Yeah.
Okay, good. And for the final example, let's try this one. 3 minus 5y minus 7x cubed minus 2 minus 1 plus 4x cubed minus y. Let me know when you're done.
I'm done.
All right. So the like terms here are negative 7x cubed and 4x cubed. That's going to give us negative 3x cubed. And then we have negative 5y and negative y. That's going to give us negative 6y. And 3, negative 2, and negative 1. Well, they're going to cancel out because negative 2 and negative 1 is negative 3. So we have positive 3 and negative 3. That's going to give us a 0. So we're just going to be left with this, negative 3x cubed minus 6y. Is this what you got?
Yeah.
All right. So that's going to conclude our lesson on variables and algebraic expressions. We're going to move on to equations, but we're going to take a short, let's do like a 10-minute break. Okay?
Okay.
Okay. Maddie, can you hear me?
Yeah.
Okay, let's go ahead and start. Okay, equations. Introduction to equations. Again, so the first two lessons that we're going to do today that we're almost done with doing variables and expressions and then introduction to equations. These are like foundational to algebra. It's very, very important that you understand it at almost like at the memory at the level of muscle memory. Okay, you want to understand these things intuitively. So let's go ahead and start. An equation is basically just two algebraic expressions on opposite sides of an equal sign. Okay, so anytime you see an equal sign, you are dealing with an equation. And certain logical conclusions follow from that equal sign. So in this example, we have x squared equals 16 versus x squared minus 16. Okay. The difference between these two is that this is an algebraic expression, an equation, and this is an algebraic expression. Okay.
Okay.
Okay. So for the first example, it says, is x equals 10 a possible solution? Okay, to find this out, all you're going to do is plug in 10 for x and see if you get a true statement. Okay. So 5 times 10 equals 25. On the left side, we're going to get 50. And on the right side, we're going to get 25. Is this a true statement? 50 equals 25?
No.
No, it's false. They're obviously not equal to each other. So this is false, and x equals 10 is not a solution. What about this one? Is x equals 7 a possible solution of this equation?
Yeah.
Yeah. So 3 times 7 plus 10 equals 31. On the left side, we're going to get 21 plus 10, which is 31. And on the right side, we have 31. Yeah, so that's true. So it is a solution. All right, let's move on. So the reason equations are important is because they allow us to solve for unknown values. Once two things are equal to each other, such as this, in this case, you can figure out the unknown value. Now, there are techniques to solving in equations that we haven't gone over yet, but even if you don't know the techniques, with certain equations like this, you can just figure it out on your own. You can do guesswork. So if this is saying 3 times x is 12. And what multiplied by 3 gives you 12?
4.
Yeah, 3 times 1 is... Sorry, I'm about to sneeze. 3 times... Oh, God. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And then 3 times 4 is going to give us 12. So x, in this case, is going to be 4. What about this one? 3 plus x gives us 36. What do you think x is going to be?
33.
Yeah. If adding 3 gives you 36, then you can just count back from 36 3 steps to get 33. Okay? 33 plus 3 is going to give us 36. So x is going to equal 33. One word or term you need to be aware of is called a domain, and that's basically all the possible values for x for which the equation is true. Okay, it's a very important concept. So here we have an example where it gives us a possible domain of 20, 15, and 30, and it's asking which is an actual solution to the following equation. So in this case, all you're going to do is plug in each value 20, 15, and 30 and see if you get a true statement for each of them. So go ahead and do that for me and let me know when you're done.
X is 30.
Well, I'm not asking for 30. You're correct that x equals 30, um, because 30 divided by 10 gives us 3. But I'm asking which of these possible solutions in the domain is in the actual domain. In other words, which is 20 a possible solution?
No.
No, because 20 divided by 10 gives us 2. And here it's 3. Is 15 a possible solution?
No.
No, because 15 divided by 10 is not 3. 15 divided by 10 is going to reduce to 3 over 2, which is 1.5. So the only solution in this case would be 30. Okay, so that's what this question is asking you. Which one out of these things is a solution? It wants you to test each possible thing.
I did.
Okay, good. What about this one? It says, is x equals to a solution of the following equation? Let me know when you're done.
I'm done.
Okay, so all we have to do is plug it in. 9 times 2, okay, 9 times 2 is 18. So we have 18 plus 21. And then on the right side, we have negative 20, sorry, negative 20. So negative 20 times 2 is going to be negative 40. Negative 40 and positive 1 is going to be negative 39. So on the right side, we have negative 39. 18 plus 21 is what? It's 39. And then you have a negative in front of it. So we're going to get negative 39 equals negative 39. And that is obviously a true statement. They are equal. So x equals 2 is a solution. Good. And for the final example, we have this thing. It says, is x equals 3 a solution of the following equation? Go ahead and try that and let me know when you're done.
I'm done.
Okay. Again, we're going to plug in 3 for x and see if we get a true statement. So 3 squared. So we get negative 12 times 3 squared plus 10 times 3 equals negative 6. Again, you need to be aware of your order of operations. We're going to have to raise 3 to the second power first before multiplying by negative 12. So this is going to be negative 12 times 9 because 3 squared is 9. So negative 12 times 9, what is that? That's negative 90 plus 18. Sorry. You can break that up into 9 times 10 plus 2, which is 90 plus 18, which is 108. So it's going to be negative 108 plus 30, because 10 times 3 is 30, and negative 6. And negative 108 plus 30, what is that? Negative 108 plus 30. So it's 8, 7. So it's negative 78 equals negative 6. Is this a true statement?
No.
No. Negative 78 does not equal. Sorry. Negative 78 does not equal negative 6. So x equals 3 is not a solution of the equation. Okay. That's it for today's lesson. When you get a chance, I need you to do practice problems or homework, okay? So if you go under Algebra 1 practice problems, this one, Algebra 1 variables variables and algebraic expressions, and then introduction to equations, okay?
When does it due?
Tomorrow.
Okay.
Okay. That's it. Good job.